Hi, welcome back. Let's keep going on problem 4. So now I'm hoping you're noticing this is an arc length. It's not the whole perimeter of the circle. In fact, the whole circle isn't even there. It's just the arc length of a quarter of the perimeter. Now we said in our notes that the circumference is technically the perimeter of the circle. So here, they don't want the whole perimeter of the circle, the whole circumference, they just want a quarter of that. And so that would just be a fourth of whatever number we get. Okay, so there's a couple ways to do that, but I'm gonna do the arc length, which we've done before. So my arc length is, if this is 90 degrees, it's 90 out of the whole 360, which interestingly enough, that is a quarter. So that's exactly the number that should make sense there. And we want to multiply by our circumference because I want a quarter of the circumference. So that fraction will reduce to 1/4, and the circumference, if the radius is 8 and the diameter is 8 times 2, so 16, my circumference is 16 pi. Make sense? So what would be a quarter of 16 pi? You can turn this into a decimal because we're going to anyway, but I like to reduce the fraction to keep my answer as exact as possible to the very end. So it looks like the arc length here would be 4 pi because the whole circumference is 16 pi. And this should make sense. So if that's 4 pi and another 4 pi and another 4 pi and another 4 pi, all the way around is 16 pi. And that should make sense. So I know the perimeter of this object, it's 8 plus 8 plus 4 pi. So you might be wondering, well, what is 4 pi? So 4 times pi is 12. Oh, okay, so that's close to what I approximated. I approximated it to be about 11, and I was a little off. I went a little too small. So that's what 4 pi is. Okay, so now I go over here. And it wasn't that, it was 12.57. So when we've got that on our calculator anyway, and I want to add 8 and 8 to that, plus 8 plus another 8, I get 28.57 feet. Nope, this one was in inches, so inches. Good job. Now, if all that makes sense, pause the video and try 5 and 6 on your own. If you're not there yet, let's do 5, and then hopefully you can do 6 on your own. Let's try. Same situation, but now I want to make it bigger. What's the perimeter of the shaded region to the nearest 100? So now instead of 8 inches, they've made it 10 inches. So this would be 10 and 10 and something bigger than 10. So I don't know, maybe 15, I'm not sure, right? So using these same ideas, my perimeter is still the same. It's 10 and some other number. Okay. And I need this arc length. So once again, there is a circle here, and I only want a quarter of the circumference, not the whole circumference. So the radius of this circle is 10 from the center to the edge. And the diameter would be 20, and the circumference would be 20 pi. But I don't want all 20 pi. I think this would be a quarter of it. So again, what you're calculating is the arc length, and the arc length would be what portion of the circumference do you want? I only want a quarter of the circumference. Again, you could write it like this as well, and hopefully you're understanding that's writing the same thing. Those would give you the decimal 0.25, 0.25. So we found our circumference was 20 pi. So either way you do it, 20 divided by 4 is 5 pi, and that should make sense. If the whole circumference is 20 pi, that's 5 pi, another 5 pi, another 5 pi, another 5 pi. So 5, 10, 15, 20 pi. All the way around, we only want a quarter of it. So let's figure out approximately how big that number is. 5 times pi is 15.7. Ooh, so I got pretty close. 15.71. 15.71 And now let's find the full perimeter. So if I walked around this object 10 and 10 and 15.71, my full perimeter would be 35.71 inches. Okay. Now pause it, try this one on your own, and let's check back in to see if you got it right. Welcome back. If that's 6, and this is a square, that'd be 6, and that'd be 6, and this would be a number a little bigger than 6. Okay, so the perimeter would be 6 plus some number a little bit bigger than 6, and we want that arc length. The arc length is, they're saying, I don't want the whole circle, I want a quarter of the perimeter of that, okay? And so let's figure this out. If the radius were 6, the diameter would be 12, and the circumference is 12 pi. So the portion of the circumference I want is only 1/12 of it, which sounds like it would be 3 pi, right? Does that make sense? So again, if all the way around the circumference is 12 pi, this much would be 3 pi, and 3 more pi, and 3 more pi, and 3 more pi. That would be 12 pi. So a quarter of it is 3 pi. Let's figure out what that is approximately, maybe about 10. 3 times pi, 9.42. Cool. So plus 6, I get 21.42 inches. Great job. Hopefully that was the answer you got. Now let's look at a different problem, but it really doesn't look that different. I see my circle and I see my square, and it's just a combination of that. But now it appears that they've gone, instead of combining things, I'm subtracting. So I want the area, not of the whole circle. So if I highlighted the whole circle, but then I cut out this square inside of here, cut out the green part, what's left over is the orange. So hopefully you're noticing that the area of this shaded region should be equal to the area of the circle minus the area of the square. And so if you can find the area of this and the area of that, you can find the area of that using logic. So let's take a look at our dimensions though. It says the square is 20 by 20. So right now, if our square is 20 by 20, we know the area of our square is 20 boxes wide, 20 boxes tall. There's a total of 400 boxes right there. So I'm going to subtract by 400. Okay. Now my area of my circle is a little more complicated. I'm going to have to redraw this. Okay, so here's my square inside my circle. They said this is 20, and that would mean that is 20. And we said a minute ago, this should be 20 times the square root of pi. That's a pattern that repeats itself, and it is very useful if we can pick up on that strategy. But now, unfortunately, this is my diameter. My diameter is 20 times the square root of pi, and I don't want my diameter to find the area of my circle. I want a radius. So I think it makes sense that if the whole thing is 20 square roots of pi, that the radius here would be 10 times the square root of pi, and this radius would be 10 times the square root of pi. That's half of 20 pi, would be only 10 pi's. If you add to, not 10 pi's, what am I saying? 10 square roots of 2. If I had a total of 20 square roots of 2, and half of that would be only 10 square roots of 2. Now I have my radius. So the area of a circle is radius times pi. I now know my radius is 10 times the square root of 2. Okay, now they want us to round to the nearest tenth. So some folks can just keep on going. They're like, yep, I can type all that in, and you totally can. 10 times the square root of 2 times another 10 times the square root of 2 times pi minus 400. That's all that stuff rounded to the nearest tenth. Inches squared. Whoop, okay. Now there would have been a cleaner way to write that if I rearrange these numbers. So if you notice, there's a 10, a square root of 2, a 10, a square root of 2, and a pi. Those are 5 numbers I'm multiplying, and any of the order is fine. So I already know 10 times 10 is 100. And I also kind of know the square root of 2 times the square root of 2 is the square root of 4. Right? And that stuff is still there. Now the interesting thing isn't the square root of 4 just the number 2? So cool, right? So technically, I could have just typed in my calculator 200 times pi minus 400, and I should get this same decimal. All of these are equivalent pieces of information. Okay, so let's try that just to double check our answer. 200 times pi minus 400. Oops, got a different answer. Let me do this. 200 times pi minus 400. Okay, so I'm going to write that down. Maybe I made a mistake earlier. Okay, so one of these is probably my answer. I got to figure out which one. So let's figure out. Maybe I typed all that in incorrectly. So let's see. Let's try it again. 10 times the square root of 2 times 10 times the square root of 2 times pi minus 400. Oh, I did get this answer. So I did type this in, but I did get a cleaner answer. But this might also give you a reason. Why would a mathematician clean this up a little bit? And there's fewer mistakes I can make typing this in than typing all of this in. So anyway, this is definitely my answer.